We are running a 3-phase induction motor with a 24-volt battery pack through an inverter that will change it to a single phase 120 volts. The 120 volt is given to a VFD that changes to a 3-phase still 120 volts, and then goes to the motor. So this operation we are doing is actually you are controlling the motor speed, okay, by changing the frequency. So you know there's a relationship between voltage and the frequency. This is an induction motor. So the stator speed, whenever there's a supply, the stator gets its synchronous speed first before it will induce voltage onto the rotor. Okay, so once you have induced voltage onto the rotor speed will be lagging the stator. Okay, you have the two parts of the motor, the stator and then the rotor. So the stator receives current first. Once it receives current, you have voltage and current completing cycles before they induce to the rotor. So that is why this is an asynchronous motor, because there's a difference in speed. It's asynchronous. The asynchronous is the same as induction motor. The other name for induction motor is asynchronous. So synchronous means the speed of the rotor and stator is the same. So the slip is the difference between them, is 0. Now for induction motor, the slip is not zero because there's a difference between stator speed and the rotor speed. So the difference is slip. Okay, so now we are controlling the speed of the induction motor by changing the frequency. Once we change the frequency, the voltage is also changed at the same time. Okay. We do this so that you have the magnetic flux to be constant. The magnetic flux, the stator and the rotor, there's a gap between them. The gap is called the air gap. That air gap, when there's a voltage to the stator induces voltage to the rotor through the air gap. So the air gap is magnetized. Once the air gap is magnetized, it induces voltage to the rotor. And so you want to keep that flux, magnetic flux between the stator and the rotor constant. If you vary them, if you increase the flux and decrease the flux, it causes saturation. It will saturate the rotor and then can bend the coils. I hope you get it. So that is why we change voltage and frequency at the same time. So we have several ways of controlling motor. You can control by using the constant V/F. We call it scalar control. So what we are doing now is called scalar control.
So we are controlling the frequency and the voltage
at the same time. Yeah. This one, it's principle of operation. Motor is similar to that of a transformer. And then the transformer formula is V is equal to 4.44 times the magnetic flux times the winding constant K times the turning number of turns T times F, which is the frequency. You see that the winding constant, once the motor is constructed, the winding constant is the same. The turning number of turns is the same. And the 4.4 is constant. So the only thing you can vary is voltage and frequency. So magnetic flux will be equal to voltage over frequency. And so these are the things. Once you change voltage, you have to change frequency so that the flux will be the same. So that's the basics, like scalar control.
Both voltage and frequency
at the same time. Yeah. So you do that in order to maintain magnetic flux. Okay. So magnetic flux, let's say the voltage is 110, and then the frequency is, let's say, 50 hertz. Okay. 110 divided by 50. That ratio, the constant you get is the magnetic flux, and we want to maintain that ratio throughout the operation. So we have several methods of controlling, but this is only one aspect, VF control method. So we can now start. Now put it to run. Okay, and then try turning the. Is it run? Can you see that now the numbers are static?
Mm-hmm.
Okay, so now try controlling it to the right, slowly, right, go. No, it will not work. Okay, you know why? Mm-hmm. The circuit breakers are open, so bring it back to 0.
Okay, run first.
So we can stop it.
Okay.
Okay, now the breakers are what?
On.
Yeah, so on it now. Run it. Okay. Now you can see the numbers are static. Mm-hmm. And then when you are running it, you can check the rotation speed of the motor, mm-hmm. the current, the frequency, the revolution. This one is reversed. Mm-hmm. This one is forward. And then the power. Mm-hmm. The LED is indicating rotation, mm-hmm. current, frequency. Okay. So if you want to change the rotation and see the frequency at which the motor is running, you use shift. If I press shift, you can see it's come to hex. Yeah. So now you can run.
Okay, so
slowly.
This, when it's on hertz, it's changed both voltage and hertz.
These ones are just indications, just showing you that the frequency of the motor.
The number here?
Yeah, the number there. Mm-hmm. So if I want to change it to, if I press it again, it will move it to this current. Okay. You want to see the amount of current the motor is drawing. Okay. So now I want to see the rotation, the speed.
Okay. Now we want to see the hex.
You want to see the hex. Okay. So move on. Slowly. Go. Are you turning it? Mm-hmm. Yeah, go. So it's starting. Go. What is the hex?
Now 600, around 600.
Go. Go. Go faster. Go faster. So go. Go full. Wow.
What do you want to reach? Like?
Okay. So you can go maximum. Is that maximum? Change it to rotation and see what speed are you running. Okay, it's on rotation. What is the speed? What number is there?
1,128.
It's not full. Go. The full is 1,700. Yeah. This maximum speed. Okay. The paper is gone, but it's still running. So you can go back, reduce the speed. Check the battery. Check the battery. How much are you consuming?
2250.51.
Okay, how much power are you consuming at maximum speed?
80.
Okay, 80 watts. Mm-hmm. And then it's drawing how much current?
0.2.
3
ampere.
3.5 current.
Okay.
Yeah. So this is just telling you the amount of energy consumed from the battery, 0.2. Mm-hmm. Okay, so if you run this way, the battery will last how many hours? 16 hours.
Mm. So it's not with the maximum speed. These numbers are not with the maximum.
Okay, I'm going maximum speed. So maximum speed, the current is what?
4.5 ampere.
Okay. You see the current is slowing down. Once you reach maximum speed, it will go down. Mm. Well, are you enjoying it? Okay.